Hey, what is up guys, and today we're going to be doing an Arduino tutorial. It's going to be a very basic tutorial, but it's going to be the beginning of a new series. Now we're going to be taking a look at how to control an LED with and without a button, as well as taking a look at the programming and seeing how it works and why it works the way it does. And then in later steps, I'm going to be showing you how to create the schematic as well as the PCB layout and have it manufactured. Now the idea of this series is we're going to start basic and then move our way up to more advanced projects until I am able to get you to come out of the Arduino Nano shell. Now what does that mean? Well, that means is basically have you not need an Arduino Nano anymore and just using the ATmega inside your PCB layout and help you with the schematic and then create your own Arduino Nano for your current project, basically a permanent project, which is the whole idea of this series. So enough talking, and let's just jump to it. All right, so first things first, we're gonna need a couple things. We're gonna need an LED, a resistor. Now the resistors can be anywhere between 100 ohms to 10k ohms, and I'll explain why in a little bit. A physical button and two dew point connectors. I'll leave a link to everything down below. You can go ahead and check it out, whether eBay, AliExpress, Amazon, everywhere, link down below, so you can go ahead and pick some up. And also we're gonna need an Arduino Nano and a breadboard. Now before we begin, you need to know how a breadboard works. Now these lines here that are in the middle are connected like this. So if I were to put something here and put something on the same row, that means these are connected. And on the bottom side here, this is a rail. So if I were to put something on the ground rail here, this whole line, this whole top line would be ground. So if I were to connect here, it would still be ground. Those would be connected inside. And then same thing goes for the bottom positive rail. This way is to keep the board overall clean and allow you to move freely when you're creating your little prototype projects. So let's get started. First things first, what we need is a ground pin from the Arduino Nano. So let's go ahead and zoom in here. All right, so as you can tell right there, we have a ground pin right here, which is called GND. So let's grab our dew point connector, and we're gonna go ahead and give it some ground, take ground from here, and we're gonna apply it to the ground rail on the breadboard here. And let's just move this out of the way, just keep it nice and clean. So now we have ground set up. So next thing we need is the LED. Now the LED here, how would you know which one's positive and which one's negative? First of all, if it's the short lead, is always negative, the longer lead is always the positive, and there's always a little flat spot by one of the pins, and that flat spot also indicates that this is the negative side or the ground side of the LED. So we're going to go ahead and get the short lead right here, and we're going to install it on the ground rail, and on the other pin or the other lead, we're going to install it just anywhere on the board. Just make sure nothing is connected there. So that's all set and done. Next thing we need is the resistor. Now you might say, well, why do we need a resistor? Well, LEDs like to take and soak up as much current as possible until they basically blow themselves. Now sometimes you can get away with using an LED without a resistor, but it's highly recommended you use a resistor. Now the values can vary between 100 ohms to 10k ohms. The higher the ohm value, the dimmer the LED will become, because the higher the ohm value, the less current will go to the LED, thus dictating its brightness. So what we're going to do is we're going to take the resistor here, and this is a 100 ohm resistor, and I'm going to put it on the rail of the positive side of the LED, and I'm just going to connect it anywhere else, somewhere else, such as on the other side here. All right, so we've connected it this far. Now what is the next step? Well, now we need to figure out a pin that we're going to use, and we're going to be using D13 for this tutorial. So let's go ahead and set up a connector on D13 here. There we go. And then the other side of the connector is going to be connected to the other side of the resistor. Now, why is it connected this way? Well, because in the program, once we take a look at it inside, we're going to tell D13 to send 5 volts to the LED. So it would send the 5 volts, pass through the resistor to limit the current so this guy doesn't blow himself out, go here, and then boot up the LED. And then now we can control the LED. So next step is to jump to the Arduino IDE and take a look how to control this and how the programming is actually done. All right, so I still have not connected the Arduino Nano to the PC just yet. We'll do that step together. Now let's take a look at the code here. It's a very simple code. It's actually 1, 2, 3, 4, 5, 6. It's around 6 lines, and these are called comments. Now anything with dash dash means it's a comment, which is not really a code. It's just allows you to know what's really going on. And it's very nice to comment your code, because after a week or two or a month, you might come back and be like, what the heck was this? What was I doing here? So it's really nice, and also something within the programming community, thou shall comment. So you should always comment into your code. Now let's go ahead and get started. So first things first, we have void setup. This sets up the Arduino Nano, and you can put your things such as it boots up, what pin to do what. So here we have pin mode 13 as an output. Now what does that mean? Now that means that pin 13 will just output data. Now you can also set it up as an input to take input data, which we'll see that when we use the buttons, but currently we want it to output. And what does it output? It just outputs voltage. So here we have pin mode, pin 13 into output mode. And now the next step is to look at the loop. Now this only gets executed once when the Arduino boots, and this is what keeps getting executed after it boots. So it'll keep executing this over and over and over and over and over again. Now, if you take a look here, we have void loop, and then we have digital write. So it's telling it to write on pin 13 and to make it high. Now you have two values here, high and low. Low means off, 0 voltage. High means 5 volts. So as you can tell here, turn the LED on. High means to enable 5 volts on pin 13. Perfect. So if we install this code right now, if we flash the Arduino with this code, the LED will just stay on. So let's go ahead and do that. So I'm going to go ahead and grab the Arduino, and I'm just going to connect it to the PC here. All right, so now let's go ahead and upload it. So first things first, we need to go check the boards, and we make sure we have Arduino Nano enabled. Now, if you're using the bigger Arduino Unos, then you would click this right here. Next step is to make sure you have the correct processor, which is the ATmega 328P. If you have the 168, you know probably what you're doing, but this is the default that all of them come with. Next is the Comport. Now, if you don't know which Comport, usually you should just have one. However, I have two because I have something else on my PC. So I know my Arduino Nano is on Comport 22, but don't worry. If you don't know which one it is, just flash on each, and once one works, then you know it works. So mine's COM22. Let's go ahead and press upload. So now it's uploading, it'll compile upload, done uploading. All right, so now as you can tell, the LED is just on. So let's go ahead and make this blink every second. So let's go ahead and add a new line after the digital write here. And we're gonna go ahead and say delay. And then we're going to put parentheses 1000, because this is working in milliseconds. So 1000 is actually 1 second. Close that line. And now we want to make the LED turn off, which is digital write 13 low, which means power off the voltage that's going to pin 13. And we're going to say another delay. We'll just copy it again, which is a lot faster, which is another delay for a second. So what's really going on here? So now when the Arduino boots up, it'll say that pin 13 is an output. So it'll just outputs voltage. And then we tell it to turn it on right here. So pin 13, output the voltage, wait 1 second, and then pin 13, turn off the voltage, wait 1 second, and then this will automatically reboot, loop again. So that's why it's called the void loop. So let's go ahead and upload this and take a look at how it will work. So now, as you can tell, the LED is turning on and off, which is really nice. Now, if you wanted to change these values, so let's just say, we'll say half a second. So what happens here is, that's not half a second, this is half a second. Okay, so it'll boot for 1 second and then turn off for a half a second. So let's go ahead and take a look at that here. As you can tell, it's blinking a little bit faster now. All right, and it's actually just that simple to control just about almost anything. Now, there's also stuff like libraries and things, and we'll get into that in later videos. And now we're gonna go ahead, and the next episode will be setting up a physical button, as well as setting the schematic for this to have this created into a PCB. Now, it's a very simple PCB, which will incorporate an Arduino Nano, just to give you an idea of how to get started with the software and the layout and everything. And then later on, obviously, we're going to get into more advanced things. And well, that's it, guys. I really hope you guys learned something today. And if you guys have any questions or any suggestions, feel free to let me know. And I will see you in the next one. Peace out, guys.